Okay, welcome back to day 2 or part 2 of variables and expressions. Now where I left you last time was I asked you to finish this table and I've checked your work and see how you did. I'm just going to finish that out. For anyone who missed today, we're just going to move these words to where they belong. More than. If I want to eat more than something, I'm going to add it. Add 8. Total, you go to the store, buy a bunch of items, you add them all up, you get a total. How about add? Obviously, has the word right in it. There we go, bring that in there. Increased by, if I have 5 times x increased by 8, I'm going to add 8 to 5 times x. So increased by is add. Alright, let's move on to subtraction. Obviously, we have more than here, less than. Whoops, let's put that one back there. Less than means subtraction. Minus means subtraction. We know that. First grade. How about less? Subtract. Obviously. The obvious one. Let's do that so it doesn't show up anymore. Here we go. So subtract. Perfect. All right. Multiplication. Multiply. Yep. Sure you all got that one right. Times, we often say. Decreased by. Nope. That's not it. We forgot one. That goes over here. 7 times 3 decreased by 10. I would subtract 10. Of. Let's quick talk about that. Maybe I can go to this quick. If I have 3/4 of 20, all that means is I want to multiply 20 by 3/4. We all love multiplying fractions. Actually, multiplying fractions are the easiest one. You don't need a common denominator, just straight across. But it's nice to cross reduce sometimes. You just have 3 times 5 is 15 over 1, which is 15. 3/4 of 20 is 15. Also, we're going to make some room now. Squeeze these up a little bit. And let's throw in double, because double, if I want to double something, I'm going to do what? Times it by 2. So remember, double, if you want to double something, it's just times 2. Alright, so obviously I think the other ones mean division except for what? Obviously plus. We forgot that one. Let's put that over here. Plus. Divide is division, we know that. Divided by, we often say. Half. I want half something. What am I going to do? I want half of it, just divide by 2, right? Okay, so that completes the table. Moving on. Now we're actually going to start doing some real work here. I did make a note here that says less than is the backwards one. Remember that blue one I had on the table? We're going to come back to that in a little bit. Just want to make a note of that. Right now, though, we're going to take an algebraic expression and basically we're just going to write it in words. So we'll just do like 4 examples here quick. I'm just going to write them up here. How about this? How about example number 1? We have this algebraic expression. Okay? I just need to write that in words. Doesn't seem too tough. Well, it's not. All that says is that first term is 4 times some number x plus 2. It's that simple. That's all we're going to do. We're going to take the algebraic expression and write it in words. Example number 2. How about this one? How do I write that in words? Well, let's give it a try. What's that first number? 7. Someone write 7. What's that little symbol? That's the minus symbol. Minus. And how do I write this? A division problem. Minus c divided by 3. Yep, that's good. We could do that. Or you can write minus the quotient of, it's probably how you're going to see it when we have to go the other way, the quotient of C and 3. Well, another example, example 3. This one. What in the world is that? Lots of ways you can rewrite these things too. I'm not going to say the way I wrote it this time is the only way to write it. If we go back to example 1, I could write 4 times x increased by 2. Or the product of 4 and x increased by 2. For example 2, I could write the difference of 7 and the quotient of c and 3. All right, there's more than one way to skin a cat. All right, this one, I would just simply go from left to right. I would say 8 times x squared. Some number x squared. Or I could write 8 times x to the power of 2. Also acceptable. Okay, here we go. Let's do one more example, a little more challenging. Example 4. How about this one? Can you write this in words? Let's get it up there. Hopefully you can. I'm sure you can. You're all very smart. So here we go. What's that first term? Well, that's the variable y, so I'll just write y to the 5th power minus (16) times y. Squeeze it on there. Okay, is there more than one way to write that one? Certainly. I could write y to the power of 5 minus the product of 16 and y. I could write the difference of y to the 5th power and the product of 16 and y. I can get a little more complicated there, but it's another way to write it. Okay. Okay, now we're going to go the other way. We're going to take a verbal expression, write the algebraic expression. I'm running out of time, so I'm going to go a little more quickly. You at home now can pause it and stop it. But here we go. All right, if I were to write the algebraic expression of a here, I could either write, and what most people write is 6 less than, we know is minus, the number z. That's wrong. Remember that one was blue? That one was blue on your table? That's the special one. You gotta think backwards. If I want $6 less than $10, I'm gonna take $6 away from that 10. So in other words, you cannot subtract in any order. You need to write this one backwards. So you'd have to write z minus 6. If I want 6 less than some number z, I need to take 6 away from it. I cannot write subtraction in any order, so that one would be wrong. If I go to part B, 8 plus the product of 3 and f. Well, 8 plus the product of, okay, the product of two numbers, 3 and f. I would write it like that. 4/3 of, we know that of is what means multiplication when we're dealing with fractions, so 4/3 of, or times, some radius r cubed. Okay. Or to the 3rd power, I might say. Or to the power of 3. All right, part D, a little more difficult. The difference of 4 times m and the quotient of n and 3. So we're looking for the difference of two terms. The first term is 4m. We want the difference of 4m and what else? Difference of is minus. The other term is going to be the quotient of n and 3. And there you have it. Okay, it's time for a real-world example here. Story problems, don't be afraid. They're really not too challenging if you take them slow. Here we go. Example 1. Mr. Thompson bought 2 adult tickets and 3 children's tickets for the new Star Wars movie. Yes, there's one coming up in about a couple of years. Can hardly wait. Write an expression that represents the total cost of the tickets. Okay, for all word problems, we want to define the variable. What don't we know? We really don't know the price of an adult ticket or the price of a child's ticket. So that's what we're going to define it as. We're just going to say A equals cost of an adult ticket. And then C would be the cost of a child's ticket. That's just the cost of one of them. Well, how many adult ones do I have? 2. So if I want a total cost of that, I would just say 2 times the cost of one ticket, A. And I want the total, so I would add to that the cost of the children's tickets, which I have 3 of, and multiply it times one of them, cost of 1. And that would be my expression. Simple as that, lickety split. I'm going to leave one for you guys that I will go around and check here in a little bit, see if you can figure that out.